Hello everybody. We talked about the unit circle in the last set of notes. Today we're going to actually do some trig with it. These are the ratios that you should know for sine, cosine, tangent, secant, cosecant, cotangent on a circle. You don't have to memorize these though because there's a little shortcut. If the radius on a unit circle is 1, then this is just y. This is just x. This is still y over x. This is 1 over y. This is 1 over x. And this is x over y. In other words, sine is just the y value. Cosine is just the x value. That's the reason the unit circle is so important. And the reason we make you memorize it is it tells you the sine and the cosine of all of the angles on the unit circle. And then you can always find the tangent because it's just y over x, sine over cosine. The way that I remember this is c comes before s alphabetically, x comes before y alphabetically. How do you remember tangent? Tangent is the same thing as slope, and slope is y over x. To find secant, cosecant, and cotangent, find the corresponding one of these. Secant goes with cosine, cosecant goes with sine, cotangent goes with tangent, and just flip them. So let's try some problems. Sine of pi over 3. You do have your unit circle memorized, right? Hopefully. If not, here it is. Here's pi over 3. The point that corresponds with that is 1/2, comma, square root of 3 over 2. So the point is 1/2, comma, square root of 3 over 2. So which of those am I going to use, the x value or the y value? Well, it's sine, so I want the y value. This is why memorizing the unit circle is so important. Cosine of 5 pi over 6. Again, if you have the unit circle memorized, this is a very easy problem. But for today, I want to make sure you get it, so here it is. Negative square root of 3 over 2, comma 1/2. Notice that a lot of these things are very similar. So, cosine is the x value, so this one's going to be negative square root of 3 over 2. Tangent of 7 pi over 4. Well, hopefully you know in the unit circle, 7 pi over 4 is this point right here. Square root of 2 over 2, comma, negative square root of 2 over 2. So, since the point is square root of 2 over 2, comma, negative square root of 2 over 2. Now what's the ratio for tangent? What's y over x? That's negative square root of 2 over 2 over positive square root of 2 over 2. Now you could flip this and make it multiplication if you wanted to, which is the correct way to do it, or you can be smart. It's the same thing over the same thing, but one's negative and one's positive. Well, negative divided by positive is a negative, and something divided by itself is 1. How about secant of 7 pi over 6? Well, where's 7 pi over 6? 7 pi over 6 is right here. And the point that goes with that is negative square root of 3 over 2, comma, negative 1/2. So the point is negative square root of 3 over 2, comma, negative 1/2. Secant corresponds with cosine. The cosine of this would be negative square root of 3 over 2. But since it's secant, I'm going to flip that. So I can just flip this to make it negative 2 over the square root of 3. Don't ever leave your answer with the radical on the bottom. I can multiply top and bottom by square root of 3 to get rid of that. And that ends up being negative 2 square root of 3 over 3. This is why the unit circle is so important. This is why you have to have it memorized. Yeah, I never did. If you can memorize the first quadrant and can understand reference angles, then you don't need to memorize the whole unit circle. Well, what's a reference angle? A reference angle is the angle between any given angle and the x-axis. All reference angles are positive and should include which quadrant the original angle was in. The value of a trig function is the same as its value at its reference angle. The only question is it positive or negative? Well, let me show you what I mean. 2 pi over 3. So let's jump back to the unit circle. Here is 2 pi over 3, right here. I want to get as close to possible, or I want to get back to the x-axis as fast as possible. So I don't want to go this way, that's too far, I want to go this way. Well, the x-axis is pi, and this is 2 pi over 3. How far is it from 2 pi over 3 to 1 pi? It's easier if you think about this 1 pi as 3 pi over 3. How far is it from 2 pi over 3 to 3 pi over 3? Well, that's just 1 pi. This is the angle is 1 pi over 3 in the second quadrant. So if I know what the measure of pi over 3 is, then I know the answer for 2 pi over 3. How about 7 pi over 6? Again, let's look at the unit circle for right now. 7 pi over 6 is right here. I want to get back to the x-axis as quickly as possible. So I'm not going to go this way, that's too far. I want to go this way. How far apart are these two things? Well, this is 7 pi over 6. This is 1 pi, or 6 pi over 6. How far is it from 6 pi over 6 to 7 pi over 6? It's 1 pi over 6. But which quadrant was it in? In the third quadrant. So now how does this help me? Well, if I can memorize pi over 3, the point pi over 6, the points for pi over 3, the points for pi over 4, and I know something about the quadrants, I can answer the questions. Now that we know the reference angle, we need to determine whether it's positive or negative. The mnemonic, all students take calculus, will help you. All students take calculus. In the first quadrant, all the functions are positive. Sine's positive, cosine's positive, tangent's positive. Here, sine is positive, cosine and tangent are negative. Students stands for S, sine. T in the third quadrant means tangent's positive. The other two are negative. And in the fourth quadrant, cosine is positive, sine and tangent are negative. So now, if I know what my reference angle is, it'll tell me the number, and I know whether it's positive or negative. So, let's try this. 5 pi over 6. Is that closer to 0 or to pi? Well, it's much closer to pi. Pi is 6 pi over 6. This is 5 pi over 6. It is pi over 6 away from being on the x-axis. 5 pi over 6 is in the second quadrant. What's the sign of sine in the second quadrant? Well, in the second quadrant, sine is positive. So, instead of memorizing what the sine of 5 pi over 6 is, I just need to memorize what the sine of pi over 6 is. I know from memory the sine of pi over 6 is 1/2. And it's going to be positive because it's positive in the second quadrant. Let's try this one. 5 pi over 4. Is pi over 4 closer to 0 or to pi? Well, 5 pi over 4 is closer to pi. If you think about pi as being 4 pi over 4, how far is 5 pi over 4 from 4 pi over 4? Well, it's 1 pi over 4. Notice, the reference angle is always in the first quadrant. That's why I only have to memorize the first quadrant. But I need to know what the sign of this angle is going to be, whether it's going to be positive or negative. This is in the third quadrant. Is cosine positive or negative in the third quadrant? Well, in the third quadrant, only tangent's positive. So cosine is going to be negative. So now all I have to do is I have to know what the cosine of pi over 4 is. I just memorized them in the first quadrant. I know that that's square root of 2 over 2. But since the angle I'm looking for isn't in the first quadrant, it's really in the third quadrant, and cosine is negative there, the answer is negative square root of 2 over 2. If you memorize the first quadrant, know your reference angle, know which quadrant your actual question's in, and determine whether it's positive or negative, you only have to memorize a tiny corner of it. What about all the points that aren't on the unit circle, like pi over 5 or 2/3 without a pi? You don't have to memorize those. You can use right triangle trig along with all students take calculus to determine the value of the trig functions. So let's use the point -5, 12. Where's the point -5, 12? Well, -5, 12 would be up here. Okay? This is the angle I'm looking for. Now, since I can't really work with that angle in a unit circle, I have to figure out this. Oh look, it makes a triangle that is -5 and 12. I need to know the third side of the triangle, so I'm going to do a squared plus b squared equals c squared, and I'll save you guys some time. It's 13. The radius will never be negative, because when I square that number and square that number, it's positive, and when I add them together, it's still positive. So now, instead of looking at this angle, I'm going to look at this angle. Sine. The sine of theta equals, well, sine is opposite over hypotenuse. Opposite over hypotenuse is 12/13. I wrote it as positive. Is sine positive in the second quadrant? Yes, that works out. How about the cosine of theta? Well, the cosine of theta is the adjacent over the hypotenuse. It's -5/13. Is cosine supposed to be negative in the second quadrant? Yes. How about tangent of theta? Well, tangent is opposite over adjacent, so it's going to be -12/5. Is tangent supposed to be negative in the second quadrant? Yes, so we're good. What about secant of theta? Well, secant of theta matches with cosine of theta. They're just reciprocals. So secant of theta is -13/5. Cosecant of theta matches with sine of theta. It's just the reciprocal. So it's 13/12. Cotangent of theta matches with tangent of theta. It's just the reciprocal. So it's -5/12. So you have to know the unit circle. At the very least, you have to have the first quadrant memorized and all students take calculus memorized. If you want to memorize the entire unit circle, which is what most people go ahead and do, that will help you as well. Okay? One way or the other, you have to be able to tell me the sine, the cosine, tangent, the secant, cosecant, cotangent of any angle on the unit circle. You also have to be able to use a triangle to find the angles that aren't on a unit circle.